Dear viewers, I am pleased to announce that, in the past month, our channel has experienced a growth of infinite magnitude. I congratulate myself. Speaking of infinite, today we'll take a look at laying some foundation for building an infinite world. Infinite worlds fascinate me. Games like Minecraft and No Man's Sky have always instilled me with awe, partly because they remind me of how insignificant I really am. An infinite amount of randomly generated content doesn't tend to get old. There's always more land to explore, more interactions to discover, and more power to be gained. Infinite worlds are great, and we intend to make Nomads infinite. But how do we store and render an infinite world? First off, let's talk about how you would save an infinite world. Obviously, the user cannot traverse an infinite amount of land. At any point in time, the player has only traversed a finite amount of land. So we can simply break down the user's traversed regions into discrete units of area, which we will call chunks. For our purposes, each chunk will be a large square with a chunk coordinate. Each chunk is made of 16 × 16 smaller squares, which we will call tiles. Each tile can then have its own terrain data. Collectively, the chunks fill a grid that can theoretically span an infinite plane. So far, we will be working with just 2 types of tiles, because I'm lazy and didn't make more. They are the empty and grass tiles. Upon starting the game, we would load all previously visited chunks into memory. During the game, if the player steps into unvisited territory, we would have to generate that chunk and mark it as visited. Upon closing the game, we would store the new visited chunks back into the computer.
But Jari, that's bad! Imagine if a player has been playing for a long time and has visited 1,000,000 chunks! Every time you start the game, you would have to wait such a long time for the chunks to get loaded!
And you're right. How do we avoid a fat loading screen every time we enter the game? We solve this by only loading the coordinates of each visited chunk, instead of the actual tile data. Naturally, we'll also need a text file containing all the visited chunks' coordinates. We defer the loading of the actual tile data until it's actually needed for rendering during gameplay. If a chunk isn't revisited, that's okay. That chunk was not needed and thus never loaded.
But Jari, that's still bad! Imagine if a player has been playing for a long time and—
Shut up. I know what you're trying to say. It turns out that reading 1,000,000 lines of coordinates is actually super fast. Let's suppose that our finished game at max can sustain a player's interest for 3 years. And let's say a multiplayer world at most can have 8 people. We'll assume a player explores on average 100 chunks a day. So let's make an educated guess and assume each world will probably always have less than 1,000,000 visited chunks. I wrote some tests to find out how long it would take to read and write 1,000,000 strings, using the Java built-in buffered reader and buffered writer classes. And as it turns out, it's super fast. But then we thought, maybe the players don't have beefy computers like Lunkle does. For comparison's sake, we ran the same test on my crappy laptop, aka Jari's gaming toaster. Again, we were surprised by how fast it was. Only a marginal increase in time. Good work, Toaster! We think it's acceptable to wait up to a second on each startup from just loading the coordinates. Is it possible to come up with a more efficient solution? Well, definitely. Are we gonna do it? Nah, it suffices. A wise man once said, if it's good enough, then you don't have to come up with anything better. That wise man is me. Okay, moving on. I've already hinted at the idea behind rendering, and at this point, you probably figured it out. We must have a camera entity that can move around the world. Each frame, you render enough neighboring chunks so that the screen gets filled up. The easy way to do this is to have a variable called render distance, which dictates the radius in which all chunks in a circle are rendered each frame. That's all there is to it. Let's see what this looks like in practice. On day 1, we made the chunk and tile classes, and we extended it with 2 subclasses, grass and empty. On day 2, we started to implement the chunk system, and we created 2 visited chunks. We temporarily symbolized loaded chunks with all grass and generated chunks with all empty. On day 3, we copied and pasted file reading for actual tile data. Changing the files also changes the map in the game. Thank you, lunkle, for the blood, sweat, and tears you've poured into this. No lunkles were harmed in the making of this video. Batteries not included, each sold separately. Now, a brief recap. Remember guys, we got chunks and we got tiles. Chunks are either visited or not visited. Visited chunks are either loaded or not loaded. When you need to render a visited loaded chunk, you straight up fetch it from memory. When you need to render a visited unloaded chunk, you need to queue it up to load from disk. When you need to render an unvisited chunk, you need to queue it up to generate from the world seed and its coordinates. Simple, really. But once you've implemented this, you can flex on your peers about how you've essentially harnessed the power of infinity.